Hi students, have a nice day. In this section, we are going to discuss about a new chapter, states of matter. What is matter? Anything which has mass and occupied in the space is called matter. And matter exists in different physical states: solids, liquids, gases, plasma state, Bose-Einstein condensate, fermions, and quarks. And the main important physical states are solids, liquids, and gases. And matter composed of atoms, ions, and molecules. In solids, the particles are very closely arranged. In liquids, the particles are little loosely arranged. In gases, the molecules are far away. Okay, the particles are not closely arranged. And we know that the interconversion of these physical states. For example, below 0 degrees Celsius, water exists as ice, solid phase. When the temperature increases, at a room temperature, water is in the liquid form. Then again the temperature increases, water is vaporizes. It converted into steam, like gaseous phase. So there are two important factors which determine the physical state of a matter. One is intermolecular attractive force, and the second is thermal energy. First of all, we have to discuss about the intermolecular forces. What is intermolecular forces? Intermolecular forces means the attractive force as well as repulsive force. In that, van der Waals forces of attraction is there. What is van der Waals forces of attraction? The weak attractive force between the non-polar molecules. Okay, attractive force between the non-polar molecule is called van der Waals forces. And the force is named after the scientist Johann van der Waals. Okay, he explained the behavior of real gases. And the other important intermolecular forces are dissipation force or London force. Dipole-dipole interaction and dipole-induced dipole interaction. Let's discuss one by one. The first one is dissipation force or London force. Okay, the first one is dissipation force or London force. Dissipation or London force. As we know that atoms and non-polar molecules, the electron cloud is symmetrically arranged. Isn't it? In atom, the positive center and the electron cloud is uniformly arranged in a spherical field. So center is positive. And also non-polar molecules. Okay, non-polar molecules, the electron is asymmetrically around the nuclei. As we know, the molecular orbitals. In molecules, the electrons are present in the molecular orbital. It is not monocentric, it is polycentric. Then another atom, let's take this is an atom A and another atom B. Okay, another atom B. The electron density or the electron cloud is symmetrical around the nucleus. However, the electron symmetrical arrangement or the symmetrical arrangement of negative charge around the positive charge momentarily changes. A momentarily change exists in the atom, and the momentarily change positive charge in the one side and negative charge in the right hand side. What happens for this B atom B? This also momentarily change plus minus. So this creates a dipole. Okay, this creates a dipole. In another situation, the electron density is towards the negative, towards the left hand side. The negative charge distorted or moved in the left hand side. The same thing happened in the case of B. Okay, in the case of B. So what happens? That dipole, the induced dipole in this direction. Okay, the induced dipole is in this left hand direction. First case, the momentarily change in the right hand side. Second case, a momentarily change in the left hand side. So now the atoms are attracted. They are interacted. Attractive force between the positive and negative. Here negative and positive. And this type of intermolecular forces is called dissipation force or London force. Are you clear? This force is called dissipation force or London force. Fritz London. Okay, Fritz London proposed these type of attractive forces, and that's why it is called London force or dissipation force. And the interaction energy, the interaction energy, interaction energy is inversely proportional to the sixth power of distance between the two atoms or two particles. Remember that. Okay. Then we can also say that the energy, the interaction energy is directly proportional to 1 by 6th power of the distance between the two atoms. So what is R? R is the distance between the two particles or two species. Okay, the next one is dipole-dipole interaction. As we know that what is dipole? What is dipole? A covalent bond is polarized. More electronegative atom with partial negative charge and the other atom acquire a partial positive charge. Okay, that means a small charge. Second one is dipole interaction or dipole intermolecular forces. Let's take HCl as an example. In HCl, the hydrogen is covalently bonded with the chlorine atom, and the electron density is shifted towards the chlorine atom, and chlorine gets a partial negative charge, hydrogen gets a partial positive charge, and the partial charge is less than the unit electronic charge. I think you know the charge of the electron 1.602 into 10 raised to minus 19 coulombs. And the partial charge is less than the unit charge of the electron. So here the electron density is more towards the chlorine atom, and that's why chlorine acquire or gets partial negative charge, and the hydrogen gets partial positive charge. That means the molecule is polarized and it has a permanent dipole. Okay, HCl has a permanent dipole. You know that. And the second molecule, HCl. Here also the molecule having a permanent dipole. Okay, so one HCl molecule is a dipole and the other HCl molecule is also a dipole. So the interaction between dipole and dipole is called a dipole-dipole interaction. Or the attractive force is called a dipole-dipole interaction. And the interaction energy in the stationary state, that is in the solid state, is directly proportional to, the interaction energy is directly proportional to 1 divided by r cube, the third power of the distance between the two dipoles. But in the rotation state, okay, when the molecule is not stationary, it is rotates, the energy. So this is in the stationary state, and this is in the rotation. In rotation state, or in the rotation, the energy is directly proportional to 1 by r raised to 6. Or we can say that the interaction energy is inversely proportional to the 6th power of the distance between the two dipoles. Are it clear? And here also the dissipation force is there. So the cumulative interactive forces increases. Dipole-dipole interaction is there. Also London forces or dissipation force is there. So the cumulative effect is increases. Cumulative effect of interaction between the two dipoles increases. Okay, are you clear? And the third one is dipole induced dipole interaction. Okay, dipole induced dipole interaction. So let's discuss what is dipole induced dipole interaction. If one molecule is having permanent, okay, one molecule with a permanent dipole and the other molecule is a non-polar, or that molecule lack of permanent dipole. This dipole creates or it induces the non-polar molecule, and the interaction is called a dipole induced dipole. Okay, so let's take this is a permanent dipole, plus charge, minus charge. Okay, the dipole is in this direction. It is a let's take HCl, no problem. Okay, so one species, so one molecule is permanent dipole, and the other is a non-polar. It has no permanent dipole or lack of dipole moments. So what happens in this situation? This negative charge attract the positive charge of the non-polar molecule or atoms. Okay, so in the next stage, plus minus, it is a permanent dipole. Okay, it is a permanent dipole, and this induces this molecule, and it becomes like this. So a permanent dipole moment molecule induces a non-polar molecule or a neutral molecule. The interaction is called a dipole induced dipole. Induced dipole interaction. This is the third one. First one is dissipation force or London force. Second one is dipole-dipole interaction. This is dipole induced dipole interaction. Okay? Yes. And the fourth one is hydrogen bonds. This is already discussed in the last chapter. What is hydrogen bond? When hydrogen is bonded to electronegative atoms such as fluorine oxygen and nitrogen. The bond is polarized. Electronegative atom is negative and hydrogen is positive. And the interaction between the hydrogen and the electronegative atom of the other molecule. Okay, the other molecule is called a hydrogen bonding. This we already learned. Okay, in water, hydrogen bonding is there. In ammonia, hydrogen bonding is there. And we also discuss the consequences of hydrogen bonding. Okay, so the important intermolecular forces are, one is dissipation force or London force. Second one is dipole interaction. Third one is induced dipole interaction. Fourth one is hydrogen bonding. Hydrogen bonding is an electrostatic attractive force between the one polarized molecule which contains hydrogen atom and with the other polarized molecule. And it is exists in the molecule having fluorine, oxygen, nitrogen. Even though the attractive force is there, there is repulsive force also. Okay, same charge repulse. Here we can say one more momentary attraction when the dipole moment is in this direction. Okay, the dipole moment is in this direction. The atom induces the dipole like this. If the dipole moment is in this direction, the atom or species induces in this fashion. When the dipole is in left hand side direction, the neutral atom or the non-polar molecule induces in this kind. Okay, you understand that. So, attractive force and the repulsive force is intermolecular forces. Next is thermal energy. Thermal energy is the energy of the body arising due to a motion of atoms or molecules in it. Even though the particles are closely arranged in the solid state, the particles vibrates in its equilibrium position. So this thermal energy is directly proportional to the temperature. What is temperature? The degree of measure of hotness or coldness. Okay, the measure of hotness or coldness is called temperature. And temperature is the average kinetic energy of the molecules or particle in the system. So when temperature increases, thermal energy also increases. That means when temperature increases, the molecule gets kinetic energy and the molecule moves fastly. And let's discuss the intermolecular forces versus thermal energy. Okay, so thermal energy is the energy of a body arising motion of a particles or molecules in the matter. And thermal energy is directly proportional to temperature. That means temperature increases, thermal energy increases. And the temperature is directly proportional to average kinetic energy. Okay, the absolute temperature or temperature is directly proportional to the average kinetic energy. Okay, yes. Next we discuss about the intermolecular forces versus thermal energy. As we already learned, the intermolecular forces which attracts the particles or molecules, they keep the particles closer. But thermal energy they separate the particles. They move the particles apart. So in solid state, the thermal energy is less. In the case of liquid state, the thermal energy is higher than that of the solids. In gaseous phase, the thermal energy is more, okay, as compared to the solids and liquids. So the interactive molecular forces, the intermolecular attractive forces is more in the solid phase than liquids, gases. So let's draw the intermolecular attractive forces. Intermolecular attractive force is less for gas than liquids and solids. It increases intermolecular attractive force. Intermolecular attraction. And what about the thermal energy? Thermal energy is in the reverse order. Okay, thermal energy is in the reverse order. Thermal energy is more for gas than the liquids, than the solids. Okay, than the liquids, than the solids. This is thermal energy. Okay, you understand this concept. Thermal energy increases, the physical state is changed from the solids, liquids and gases. That I already mentioned. When the water takes below 0 degree, okay, the thermal energy is less, the water exists as ice, the solid phase. When the temperature increases or thermal energy increases, solid ice converts into liquid water. Again, the thermal energy increases, the liquid water converts into gas. Okay, this you should keep in your mind. The next is gaseous phase. What are gases? Gases, the molecules are very far away. They are far apart. They are loosely arranged. And that's why gas molecules are compressible. Gases can be compressed. They have no definite shape, no definite volume. Okay, the volume of the gases is equal to the volume of the container in which it kept. And also the shape also the container shape. The attractive force between the gas molecules are negligible. In practical, we consider the attractive force between the molecules. Gas molecules are negligible. Okay. Then the kinetic energy of the gas molecule is higher. The diffusion nature is more for the gaseous state than the liquids and solid state. So let's discuss some laws behind the gases. That laws are called gas laws. In the next section, we will discuss gas laws in detail. Thank you.